Okay, here's our 7.1 lesson. We're going to talk a little bit more in depth about this tomorrow. So tonight you're just going to get the basics of how to find and state rational solutions. So let's just break down for just a moment. Remember that solutions, when we talk about polynomial equations, something that you may want to write down is that the number of solutions is equal to the degree of the polynomial. Okay, so that would mean if you have something like 3x to the fifth plus 2x squared minus 5 equals 0, the degree here is the highest exponent, which means in some form this equation right here has 5 solutions. So just keep that in mind. That's how we know the total number of solutions. So today, specifically, we're talking about rational solutions and rational numbers. I just want you to remember our rational numbers are anything that can be written as a fraction. So it doesn't necessarily mean that it's going to be a fraction, but anything that can be written as a fraction. And those can be positive or negative. So for example, we could have like -1/2 or +8. Remember, whole numbers can be written as fractions if we put them over 1. So +8 or even 0, right? Those are all rational numbers. Things that wouldn't be rational would be like the square root of 17. Since that doesn't have an actual square root, that's not rational. Just kind of so you keep that in mind. Okay, so this is a big deal up here in the top. What you want to write down is this thing called the rational root theorem. And what the rational root theorem does is it gives us all of the possible rational roots for a given polynomial. Now, we talked about we're going to shortcut and kind of find our first one using a table, but if you ever have a problem where you're not allowed to use a calculator, or just in general, like you need somewhere to start, know that this is a very important theorem. So what the theorem says is that we can list all the possible roots of a function. It'll give us a place to start, and we can do that by listing the factors of p over the factors of q. And if you look here at this equation that they give us, p is the number at the very end. Notice it's the one without any variables. And q is the coefficient at the very front, in front of the first variable there. So if I work this first one for you, just kind of so you can see, p is my 2 right here. And think about my factors of 2. Those are any numbers that multiply to give me 2. So that's just 1 and 2. And it's actually plus or minus 1, plus or minus 2. And then q is my 15 here. And if I think about my factors of q, I can do 1 and 15. I'm leaving off the plus minus just so it looks a little simpler. And I could also do 3 times 5. Those are my only sets of numbers that go into 15. So when it says list all the possible, I need to make all of the combinations of fractions that I can, where I'm going to do p over q. So I want to put my p values on top. So that's going to be, I have plus or minus 1 over 1. So I'm picking the first q value. Or plus or minus 1 over 3, plus or minus 1 over 5, plus or minus 1 over 15. So notice those are 4 possible options now, right? Because I have +1, -1, +1/3, -1/3, so on and so forth. So that's all of my ones with the 1. And then if I keep going, now I can do plus or minus 2 over 1, which is just 2, so I'm just going to leave it like that. Plus or minus 2 over 3, plus or minus 2 over 5, plus or minus 2 over 15. And that's our answer there. Now, notice those are not solutions. You probably want to label in your notes that these are possible rational solutions. It doesn't even make sense that they would all be solutions because this problem has a degree of 3, so only 3 of those could be solutions. But just think kind of big picture. If you didn't have a calculator, that's why this theorem is so super helpful, because it gives you some numbers to try to start. So if we do this bottom one together, we're going to do the same thing. So remember, right here is my P. So you want to take a second to list all the ways to get 8. So that's 1 and 8, 2 and 4. And then here's my Q, which is 1 and 2. And we're just going to go through and make our fractions. So what I want you to do is pause and see if you can list out all the fractions and then compare with what I'm going to get and see if we get the same thing. All right, and here's what I have. So 1 over 1, I just wrote as the whole number, 1/2, 2. Notice the ones that I wrote in white, I'm continuing the pattern, but they're actually repeated because 2 over 2 is the same thing as just 1. So really, I don't need to even write that one. 4 over 2 is the same thing as 2, which I already have, so I don't need to write it. And 8 over 2 is the same thing as 4, which I already have, so I don't need to write it as well. So those are my possible rational factors. Okay, so now here's one problem where we're going to go all the way through where we find all the zeros. And we're going to use that theorem to give us a place to start. Okay, so what I want to start by doing is just listing what are the possible rational roots. So my possible rational roots, we're going to do the same thing. Here I've got P. My Q, think about the number that's in front there. My Q is just 1. So my factors for P are 1, 3, 5, and 15. Remember, I'm just listing the numbers that multiply to give me whatever number I'm looking at. So my possible rational roots are plus and minus. All of these are over 1, so plus and minus 1, plus or minus 3, plus or minus 5, plus or minus 15. And if you didn't have a calculator, which this is possible for your state test, if you didn't have a calculator, these are 8 possible answers that you could start with to try to narrow down some solutions. What we're going to do, though, is assume that we have a calculator and use our table to find a value to start with. So since you may not have a graphing calculator with us, I'm going to do that for you and give you one to choose to begin. Okay, so we remember if this is what our table looks like in our calculator, that we have a 0 right here. So the value that I want to try first is 3, and we're going to use synthetic division to kind of break down what that's going to give me next. So I'm going to write my coefficients, 1, 3, negative 13, negative 15. Just remember when I work out my synthetic division, I'm going to bring the first one down. So that's 1. And then we're just going to multiply and add. So 1 times 3 is 3. Add together, I get 6. 3 times 3 is 18. Add together, I get 5. 5 times 3 is 15. Add together, I get 0, which proves that that is a solution. So one of my zeros is 3. And I can go ahead and list that one off to the side so I don't forget it. Because this is a x to the third, I know I should have 3 roots total. So we're going to keep going and see if we can find the other roots. Remember, too, from synthetic division that these are now coefficients. And I'm going to start counting down. So I had x to the third. So this is now 1x squared plus 6x plus 5. And because I want to solve this, just like normal, we're going to set it equal to 0. Now you could keep listing rational roots, so we could kind of do our theorem again. So I'm going to show you kind of that option. If we do our theorem again, that just shows us that we've got plus or minus 1, plus or minus 5. Or, so that gives us 4 things to try. What I think is easier, though, is just to think about this right here. And instead of doing that, I think the best option is to factor. So if I were taking notes, I wouldn't even write this side down. I would just say, now we're going to factor that. So we want 2 numbers that are going to multiply to give me 5. And I want them to add to give me 6. And those numbers should be 5 and 1. 5 and 1. If you think about your theorem, if you tried to pick, I didn't even write that right. If you try to pick 2 and 3, remember, first of all, that's not even going to work, but it's not even in our list, so I know it's not an option. So when I factor, if I've got 5 and 1, that means my factors are x plus 5 and x plus 1. and I want roots or zeros, which means I need to figure out what will make these equal to 0. So my actual roots here are -5 and -1. So my last solutions that I want to write down are x equals -5 and x equals -1. So we listed all the possible, just kind of go back through and see the steps. Listed all the possible, used a table to find our first value, synthetic division to find a new, simpler polynomial to factor, and then because this was x squared, we just use our quick factoring rules to factor that out and find our 3 solutions. The last thing that I want you to note about today is because now that we have the 3 solutions, we can actually write this in factored form. So if I went back to write the whole polynomial, the new factored form, this is not what this is asking, but I'm just trying to tie some things together for you. If I was to factor out x to the third plus 3x squared minus 13x minus 15, that's the original problem. I'm not just making those numbers up. If I wanted to factor that out, it would be x minus 3. Remember, opposites. Think about your opposites. And then if I'm pulling all these roots down, I would get x plus 5 and x plus 1. That's the same factored form of the equation. Okay, so really what you need to know is what's the process of finding rational roots. Finding rational roots. So I just need you to recap, and you need to understand when we talk about P's and Q's tomorrow, what am I talking about? How am I figuring out all the possible rational solutions?